Good morning, ladies and gentlemen. Welcome to Huawei Showcase session titled From 5G Verticals Towards 6G. My name is Monty Omonov and I work for EU Public Affairs and Communication Department of Huawei Technologies in Brussels. I'm delighted to introduce you my esteemed colleagues Marcus Dillinger and Joseph Eichinger. Marcus, prior to joining Huawei, had several positions in wireless research and development for 2G, 3G, 4G of Siemens and Nokia. In 2013, he joined Huawei European Research Center as head of wireless internet technologies, where he runs private and public research and development programs for car-to-car and their automation, supporting 3GPP standardization and normative work for the vertical industry. In September 2016, he was appointed as executive committee member of 5G Automotive Association and reassigned in following years. He was the initiator of 5G Automotive Association and leads our Munich research team regarding their technical contributions to 5G Automotive Association and 3GPP. Joseph joined Huawei in 2013 to strengthen the 5G research team in Munich. Upon graduation from university, he joined Siemens in 1994, working on the development of high-frequency radar systems, optical networks, and as researcher on radio technologies. He changed to Nokia Siemens Networks in 2007 as LTE product manager and was also head of LTE Advanced Fast Track programs from 2010 to 2012 to push forward LTE-A. Currently, he is leading our research on 5G-enabled industrial automation at Huawei Munich Research Center. The focus of his research is on 5G for Industry 4.0 and vehicle-to-vehicle communication. Since April 2018, he is member of 5G Alliance for Connected Industries and Automation steering board and head of the Huawei delegation. Marcus will present videos of 5G verticals in relation to connected, cooperative and automated mobility. And Joseph will present videos of 5G verticals in relation to industrial automation. I hope those videos are useful for you. Let's now look at the videos. Thank you.
Hello, everyone. In the following, we show you some of the 5G video material. Before you can enjoy them, I would like to give you some background and introduction to these movies. 5GA stands for 5G Automotive Association. It was founded in September 2016 with 8 founding members in Munich, Germany. Huawei is one of these initiators, and since then, 5GA has attracted more than 120 global and local players. My name is Marcus Dillinger. I'm one of the 5GA officers responsible for the management of 5GA. 5GA is a technical-driven and business development organization for vehicle OEMs, mobile network operators, suppliers, chip makers, network vendors, road operators, and standardization organizations such like 3GP, SAE, and so on. 5GA has almost all global giants on board. It combines actually the short and long-range cellular communications, edge computing, network solutions for connected automated driving, which will come in the next couple of years. In the following 5GA videos, we further introduce the audience to the 5GA background, use cases, and market insights. Some videos are taken from our quarterly plenary meetings, where we run usually demos up to externals. Other videos are educational to explain more complex use cases without audio. The last video shows the market uptake globally. So I hope you will find this 5GA video segments very useful and enjoy it. Bye-bye.
Transportation's changing. It's becoming connected, automated, shared, intelligent. In order to achieve better safety, less congestion, lower emissions, and more comfort. This revolution requires global solutions. 5G Automotive Association, a unique platform focused on end-to-end connectivity, for future mobility, bringing together the automotive and telecom sectors, automotive manufacturers, mobile operators, component and OEM suppliers, communication system providers, chipset producers, infrastructure vendors, in close collaboration with road authorities and road operator communities, committed to leveraging the full potential of CV2X and 5G for intelligent transport services, enabling vehicles to communicate with each other, other road users, infrastructure, and cloud solutions, using both direct short-range communication and long-range mobile networks. The growth of 5G AA mirrors the global momentum to bring connected vehicles to the road. Over 115 companies working together in results-oriented working groups and work items, evolving, testing, and promoting cellular communication solutions, supporting standardization with 3GPP and others, accelerating commercial availability and global market penetration, bringing together top professionals 4 times a year, raising the profile of CV2X at key events, organizing technology demos. The first CV2X solutions are commercially available from multiple suppliers. CV2X is proven, cost-effective, future-proof, scalable, and it's here. Get on board. Together we'll pioneer the digital transformation in the automotive industry. Let me introduce you to what we call Cellular Vehicle to Everything, or CV2X. It's this family of technologies that allows vehicles to really connect with their surroundings. Your car becomes a moving data center that can share the information captured by its sensors with the entire transport ecosystem, making it safer and more efficient. The beauty of CV2X is that your car can basically talk to another car by sending a quick message through what we call CV2X Direct Communications. This works even when there's no network. Alright, let me give you an example. So, imagine you're about to make a left turn, but a speeding car's incoming in your blind spot. Your car will anticipate and alert you in real time, avoiding a potential crash. And it doesn't even stop there, because that's when the CV2X mobile network communications mode comes in. Sending messages via the cellular network, it can relay information to even more distant cars, creating a whole transport ecosystem that's safer and intelligent. A traffic jam 2 kilometers ahead? Your car will know and plan its journey long before you could. And what's great is that it's not only cars that can receive the message. It's transport infrastructure, it's pedestrians and cyclists through their mobile devices. Can you imagine the implications? Already today, there are more than 180 million connected cars that have the ability to operate basic V2X applications via existing 4G and LTE cellular networks. From 2020, LTE V2X Direct Communications has begun enabling more safety and traffic efficiency applications. But to make advanced safety and automated driving a reality, we need to go one step further, and the next step is 5G. With super-fast yet ultra-reliable connectivity, 5G V2X will allow vehicles, road infrastructure, and other road users to coordinate trajectories, anticipating each other's maneuvers both inside and outside network coverage, making the roads safer and greener for all. Today, close to 200 million vehicles are already connected via cellular networks. They exchange valuable data on road safety and traffic efficiency. Since 2017, the CV2X standard also includes direct communications, operating outside cellular network coverage. This allows vehicles to communicate with each other and everything around them. Since 2018, chipsets have been available on the market and incorporated in onboard and roadside units. In China, all automakers are ramping up CV2X nationwide with strong government support. 15 vehicle manufacturers have announced the launch of CV2X in vehicles starting from 2020 onwards, and many provinces are installing roadside equipment. In the US, the industry has also put forward ambitious commercial plans. Ford will deploy CV2X in all new US vehicle models as of 2022. Audi, in cooperation with Qualcomm and the Virginia Department of Transportation, began an initial CV2X deployment in 2020. Many other local agencies and states are gearing up to deploy CV2X roadside equipment, starting with Colorado in 2018, as well as California, Virginia, Georgia, Texas, Utah, Florida, Michigan, and Hawaii, with many more to follow. In Europe, BMW was the first automaker to announce the launch of a car model with 5G capability in 2021, and many other European automakers have outlined their commitment to CV2X. CV2X builds on decades of research and innovation on intelligent transport systems, led by major standards organizations in main world regions. CV2X is proven, trusted, and ready to hit the road.
Dear ladies and gentlemen, my name is Joseph Eichinger. I'm from Huawei and since 2018 also 5G ACA board member. 5G ACA means 5G Alliance for Connected Industries and Automation. Why did we start this association in 2018? The idea was to bring two big camps together, two big industries. One is Industry 4.0 related, factory automation, process automation, to some extent also interlogistic. On the other side is 5G network. 5G network was at this time, at the very beginning, with release 15 standardization, and it promised to support ultra reliable low latency communication, massive machine type communication, and some more. This combination could enable new applications and use cases, and for sure at the end lifting the Industry 4.0 to the next level. What are currently happens is we have 81 members from OT and ICT industry. OT means here operational technologies and with industry automation industries, machine builders, end users, and much more. On the ICT side, there are chip manufacturers, network infrastructure providers like Huawei, network operators, and so forth. Academic and other organizations are also welcome in 5G ACA to complement the setup. Why do we think this 5G is a perfect enabler for Industry 4.0 based factories in the future? It's basically because of the new KPIs, of the very enhanced KPIs. The data rates, what we see here is 20 gigabit per second. This is very important for all, let's say, broadcast services, smartphone users, camera users, and so on, and supported for with release 15, what you can already buy on the market since 2019. What comes up is now release 16, and this promise and will also support latencies of less than 10 milliseconds down to 1 millisecond, but, and this is important to know, in combination with an extreme high reliability of 99.99% or even more. Positioning is also one feature what is of interest here, and the localization accuracy here is up to down to 30 centimeter. Slicing is one of the big parts of the standardization solution in order to connect different levels of factories, different stakeholders in the business model, but also different campus areas in a bigger factory environment. Another feature is the support of non-public networks. 5G ACIA is working in different work items on a huge number of topics with all of the members, and at the end we produce white papers, but also internal report. 9 white papers have been published in the past. 2 more are recently, and some more are in the pipeline. I just want to address here that we have now recently published integration of 5G with TSN. TSN stands for time-sensitive network. It's about real-time processing, real-time transportation of data in a highly reliable manner. And another one was about the exposure of 5G capabilities to enable a tight integration of factory and networks and mobile radio 5G networks. Just an example for upcoming white papers is integration of 5G into production networks by means of digital twin, and white papers about test and verification. You are welcome to join the webpage and in order to download all of the materials. You're also welcome to join 5G Asia for sure. And now at the end of this story, and I would say thanks at first for joining this short introduction. And the next, I would like to hand over to a video that shows some selected use cases and explains why and how they will be beneficial for the factory in future. Thanks a lot for joining.
A new era in industrial production. Welcome to 5G ACIA. What will factories look like in the age of the industrial Internet of Things? 5G makes the answer tangible. 5G will play a key role in delivering entirely new levels of flexibility, versatility, productivity, and efficiency. Let's look at 4 areas: logistics, factory automation, human-machine collaboration, and process automation. 5G campus networks provide the connectivity needed for new services and automation technology. They enable devices both inside and outside a factory to communicate and collaborate directly. For example, a truck can not only notify the devices inside a factory of its imminent arrival, but also conduct the handover seamlessly. Logistics processes can be adapted and optimized within milliseconds and with unprecedented precision. 5G will enable URLLC, that is to say, ultra-reliable, low-latency machine-to-machine communication. In our example, goods from the truck can automatically be picked up and transferred to a factory train. Within the factory's 5G network, new technological capabilities such as network slicing, closed loops, and edge cloud computing will pave the way for Industry 4.0. Cameras can automatically check the quality of inbound goods, and data is exchanged between multiple micro-networks. These edge clouds can monitor and manage factory equipment with remarkable speed and accuracy. If AGVs navigating the factory floor encounter obstacles, they can warn other mobile devices. Each edge cloud can reliably detect equipment malfunctions and rapidly identify ways to resolve the problem. During a repair, the edge cloud temporarily transfers production tasks to a neighboring robot cell, keeping disruptions to a minimum. 5G will also take human-machine interaction to a new level. For instance, It can give workers access to augmented reality for maintenance and troubleshooting. A remote expert can provide instructions directly via an AR headset.
He's the head of Huawei wireless research. In 2011, Dr. Tong was appointed the head of communications technologies labs at Huawei. Currently, he is the Huawei 5G chief scientist and led Huawei's 10-year-long 5G wireless technologies research and development. Prior to joining Huawei in 2009, Dr. Tong was the Nortel Fellow and also head of the Network Technologies Labs at Nortel. He joined the Wireless Technology Labs at Bell Northern Research in 1995 in Canada. Dr. Tong is the industry recognized leader in invention of advanced wireless technologies. Dr. Tong was also elected as a Huawei Fellow and IEEE Fellow. For the past 3 decades, he had pioneered fundamental technologies from 1G to 5G wireless and Wi-Fi, with more than 490 granted US patents. Dr. Tong is a fellow of Canadian Academy of Engineering, and he serves as board director of Wi-Fi Alliance. Let's now look at the video of Dr. Tong. Thank you.
A vision to take verticals to go extra mile. In the past year, the deployment speed of 5G is unprecedented in terms of network build and user adoption. The 5G momentum is surpassing all the generation of technologies we had witnessed before. For example, the number of commercial 5G networks deployment have increased 18 times. Today, 140 commercial 5G networks are up and running. The number of 5G user terminals has increased by 17 times, and 550 types of 5G devices are available today. The number of 5G subscribers have increased by 250 times. The 5G user at the end of 2019 is 1 million, and the number of 5G users today is 250 million. The true revolution of 5G is happening by opening new landscape of a digital transformation of all the verticals and the business. Let me begin here with a clear statement that 6G and its innovation will be the engine of a society of intelligence in the 10 years and beyond. The mission for 6G is to construct and build the brand new platform, new network, new infrastructure, and the new societal fabric. The goal for 6G is to drive the digital economy to the intelligence economy. And in addition, to bring the intelligence for good to every people, every family, every organization. Therefore, the wireless technology is not only for the efficiency and the productivity for our daily life, and in turn, it generates more wealth, as they did for the previous generation. But rather, 6G will benefit for the human beings as whole and meet the societal challenge of our common future. For the business point of view, it is very clear the importance and the essentiality and the fundamental of connectivity become truly critical than ever, since the entire economic and everyone's work and life is built on the fabric of a connectivity. Connectivity is not just a connect the people, but connect everything. It is like electricity to the digital economy. In our joint study with Oxford University, we see the trends and opportunity of worldwide GPT increase driven by the strong growth of our ICT sector. From the 20 years period, that means from 2005 to 2025, the traditional economic growth will be at a slower speed. The next is the digital product. However, the most growth area is the digital economy powered by the momentum of vertical digitization. With the catalyst of a 5G, the ICT spending in this sector is about 23% increase in 2023, and it will be approach 50% increase in 2025. The wireless mobility industry remains one of the hotspots for the drivers of the worldwide GDP growth. With the global rollout of 5G, these trends will be more significant. This is the path for the intelligence IoT and the intelligence economy. 6G is the next generation advanced mobile communication system, but it will go far beyond communication. 6G will serve as a distributed neural network that provides a communication links to fuse the physical, cyber, and biological worlds, truly unleashing an era in which everything will be sensed, connected, and intelligent. This in turn will lay a solid foundation for intelligence of everything in the future. In this presentation, we would like to highlight 6 most intrinsic features for 6G. The first one, 6G will build up a native AI capability. Its AI interface and network design will leverage end-to-end AI and machine learning to implement customized optimization and automated OAM. Not only this, each 6G network element will be natively integrated communication, computing, and sensing capability, facilitating the evolution from centralized intelligence in the cloud to ubiquitous intelligence on the edges. A distributed machine learning architecture built on deep edge intelligence will be the key to meet the large-scale intelligence requirements of the future society and manufacturing. For the new 6G network of machine communication, we can look into the problem from the perspective of communication, not at a bit level, but at a semantic level. This was a dream for more than 70 years. It is possible today because the machine learning becomes a reality and a very powerful enabler. In this case, deep neural networks performs information processing at the transmitter side and the receiver side as well. Because both transmit neural network and the receive neural network are both capable to perform machine learning tasks after training and learning. Both the information source and the information sink have the mutual understanding of the intelligence they have learned before. With more and more big data training, both neural networks can, with a smart information bits, to communicate the meaning at a semantic level. The second one, 6G will have a networked sensing capability, driven by the continuous increase in the frequency bands bandwidth, and antennas. Communication system will integrate wireless sensing capability to explore the physical world through radio waves, transmission, echoes, reflections, and scatterings. They will also provide high-resolution sensing, localization, imaging, and environment reconstruction capability to improve the communication performance and to support a broader range of network service scenarios, laying a data foundation for building an intelligent digital world. The third one, 6G will provide universal high-performance wireless connections and the ultimate experience with the speed comparable to optical fibers. Terabits per second peak rate, 10 to 100 gigabits per second experienced the data rate, sub-millisecond level of latency, a tenfold increase in the density of 5G connections, centimeter level localizations, millimeter wave level of imaging, and end-to-end system reliability based on the controllable error distribution will not only enable human-centric immersive services in the future, but also accelerate full-scale digital transformation and productivity upgrade for the vertical industry. The fourth one, 6G will integrate terrestrial and non-terrestrial network. A large number of low or very low orbit satellites will be deployed to form a mega constellation in the non-terrestrial network. This wireless network in the sky will expand the coverage of the terrestrial network cellular infrastructure and empower new low latency solution for ultra-high long-haul transmission. To provide continuous high-quality service to user anywhere in the Earth, both networks are expected to be deeply integrated as one system, where the terrestrial and non-terrestrial network nodes can be treated as a base station in a similar way, enabling user to leverage the advantages of each type of a different services condition. The fifth one, the 6G network will integrate various capabilities such as communication, sensing, computing, and intelligence to make it necessary to redefine the network architecture. The novel network architecture should support native trustworthiness and can be flexibly adopted for tasks such as collaborating, sensing, and distributed learning to prolific AR application on a large scale. Data, as well as the knowledge of the intelligence derived from the data, is the driving force behind the 6G network architecture redesign, and the new network feature will be developed to enable end-to-end native trustworthiness. These include new data governance architecture supporting the data compliance and monetization, such as advanced privacy protection and post-quantum security technologies. The sixth one, green and sustainable, is the core requirement and the ultimate goal for networks and devices designed in 6G. By introducing the green design concept and the native AI capability, 6G aims to improve the overall energy efficiency by 100 times across the network to limit the overall energy consumption of ICT infrastructure and terminals exceeding the level of 5G, while also ensuring optimal service performance and experience. As the core infrastructure of a digital economy, 6G will make a unique contribution to the sustainable development of humankind. At high level, to summarize, in addition to the wireless technology innovation as we talked above, overall, there are several key factors that will impact and shape 6G wireless network architecture. Number one, the primary motivation for 6G network architecture evolution is AI. In 6G, AI will be the dominant service and applications. Number two, because the primary new spectrum for 6G will be millimeter wave and even terahertz, we have an excellent opportunity to apply wireless sensing capability. In this case, the entire wireless network is a sensor network. The wireless network and the device can do real-time sensing. Number three, 6G will be effectively become the fabric to link between the physical world and the cyber world. From this perspective, the key feature for radio access network are shown in this chart. First, from the cyber world to physical world, this is the typical downlink. The primary service will be virtual reality for anything, and to access any digital copy from the cyber world. Then the wideband tactile channel as augmented neural system for the physical world. And then the inference channel for exchange to train the AI engine to the end user. Second, from the physical world to the cyber world, this is the typical uplink. The primary application is sensing and collect the big data for the machine learning. Now, how to compress the huge amount of big data to the network for machine learning? This is a new challenge. And we are working on to apply the information bottleneck theory to explore the new compression technique to train the deep neural network. On the network side, we have 6G base station node and 6G edge node. For the base station, we will have both sensing capability to sense the environment in real time and the machine learning capability. The edge node will be mostly used for machine learning as well. In this sense, classical data center is the neural center and the base station is the neural node. For the fiber optical links between the neural center and the neural node, quantum key distributing technology can be deployed. The last new element in 6G is the massive low Earth orbit satellite constellation to build up the integrated non-terrestrial and terrestrial 6G network for the ultimate full Earth coverage. In summary, 6G will offer extreme connectivity capabilities to the verticals. 6G will remove all the barriers of connectivity. 6G will take the vertical business into a new world of everything sensed, everything connected, and everything intelligent. Thank you all for your time.
Well, welcome back. Marcus, Joseph, thank you very much for your very interesting videos. We have received many questions from the audience. Unfortunately, we will not be able to answer all of them. So let me quickly ask one question for Marcus. How will the vehicles communicate with each other with no availability of 5G V2X mod? Also about pedestrian communications, how do pedestrians and cyclists can communicate with other vehicles, especially when they do not have a V2X enabled device? This question was asked by Surya Rajurkar of Continental. The floor is yours, Marcus. I think you are muted.
You should understand this. Thanks again, Momchil and Surya, for this question.
I think one point is certainly, as we have seen in the video, all new cars will have LTE modules. BMW announced 5G modules end of this year. So 5G will gradually also move into new cars the next coming years. But for the time being, we can use the existing cellular network to exchange warnings and other things like diagnosis services. In particular, we want to use also cellular technologies on the short range to have higher efficiency when we have the same technology in the long range and short range. So for the VIUs, I think the VIUs can be warned. So the pedestrians, the cyclists can be used, can also use V2N or cellular networks to get warnings from approaching cars. For that, you can use positioning technologies in cellular networks, but also you can make use of short-range technologies, LTE V2X, to exchange warnings between cars and cyclists. So that's just my answer to that. Yes, thanks.
Thank you. Thank you very much, Marcus, indeed. And Joseph, we have also received a question from the audience for you. Apart from Industry 4.0 and indoor use cases, could you please show some light on outdoor use cases like primary industries in rural areas or huge fields where public Wi-Fi networks are not available? How private networks can be implemented? What are the requirements that are needed, especially in the physical layer?
Also, if you want to build up a factory or something like this in a rural area, or maybe even a couple of factories in an industrial area in far away from cities, you can do this. You can build your own private network, at least in Germany, because this is always depending on the frequency licenses what you need for this purpose. In Germany, you have the possibility to ask for a private license in the 3.8 gigahertz band, but also in the millimeter wave band recently, and then you can build up your private network with your preferred supplier. It could be, for instance, Huawei, but also third parties that help you here in this case. And then you can connect this subnetwork based on some fiber or other network types to the operator somewhere far away from you. But you have to have anyhow a fixed network-based connectivity if you plan a factory somewhere outside, and therefore this is needed. If you have just some sensor applications what you want to deploy in a maybe a water pump station or somewhere else, then 5G can also help, because here you have a fixed setup. You can use increased transmit power. You can use directional antennas, and 5G has really excellent technologies for beamforming and for to support directional connectivity, even with millimeter wave. Yeah.
Thank you very much, Joseph. Well, I propose that we close our showcase session today. Thank you again all for attending, participating, and I wish you a pleasant day.
Thank you very much.